All right, so this is going to be part 2 of the Honors Geometry Study Guide for the first quiz. And this one, last problem, is a little bit of a doozy. It flows logically, and hopefully once we get through it, you can kind of see how the connections are, but it does take some intuition to make them. So in the diagram below, AC is congruent to CE. So I know that the big piece here, AC, is going to be equal to the big piece here, CE. All right. D is the midpoint of CE. So D right here is the midpoint. Well, what does the midpoint mean? The midpoint means that the left and the right side are congruent. How do I show that? Well, I just put a little marking on there, right? Boom, boom. That shows me that they're congruent. I'm going to kind of mark this as I read it here, both to save some time and so I can know what's going on. If CE is 10x plus 18, so let me draw that out here. If C to E is 10x plus 18, and DE, so this little guy right here, is 7x minus 1. 7x minus 1. And BC, this little guy right here, is 9x minus 2. Figure out how big AB is, this guy right here. We want to know. All right, well, there's really not much I can do with this side right now, right? Because B is not in the middle. It doesn't tell me it's in the middle, and it doesn't look like it is either. So I can't really combine anything here, right? By the way, you can't just put an x in here because you've already used x as a variable. So you could call this like, lowercase g or something like that if you want to, but you can't call this x if you've already used x as the variable because we don't know how this side relates to the others. So if you were thinking that just putting an x here, that's something you actually can't do. So I can't really do much with this side. But I know a lot more about this side over here. I know that the full piece is 10x plus 18. And I know that 1/2 is 7x minus 1. Well, if this half is 7x minus 1, and I just marked that they're congruent, that means that this other half over here also has to be 7x minus 1, this guy right here. And now I have an equation I can make, right? I can say that 7x minus 1 plus 7x minus 1 are both going to combine to give me 10x plus 18. So 7x minus 1 plus 7x minus 1 is equal to 10x plus 18. Now I can actually go about solving it. So combine the 7x's, 14x minus 2. Over here we have 10x plus 18 still. I like to move my smallest variable, 10. So minus 10x. Once again, you can kind of skip through this part of the video if you know your algebra. I'm just doing this for those that want to be extra sure. Add the 2. 4x equals 20. And we get x is equal to 5. All right, so we found the key thing. We found that x is 5. So now I can actually start figuring out how big pieces are. So first thing I might be interested in doing, because you might be wondering, where do I plug in the x now? Because again, there's a bunch of places to plug it in for, and I don't really have any direction. Well, if I want to find AB, I want to start knowing about how big this side is, yeah? Well, a good thing to do would probably be plugging 5 into the 9x minus 2, right? So 9 times 5 minus 2 would be 45 minus 2 would give us 43, right? So I know that is going to be how big BC is. So this guy right here is going to be 43. Now, if I knew how big the entire piece right here is, if I knew how big AC was in total, I could just take that entire length, subtract it by 43, and then now I have how big AB is. That'd be great, but I don't. But I kind of do. Because it says here, AC is congruent to CE. So if I can figure out how big CE is, I can just copy that answer for this length. Well, luckily, I have something to plug in for. I have 10x plus 18, and I know what x is now. I know that x is 5. So now I can go ahead and do 10 times 5 plus 18. So that would be 50 plus 18, which would give me 68, which is how big CE is. Right? There we go. So I know that this entire length from C to E is 68. Great. And now I also know that the entire length from C to A is also 68 because, again, the two things are congruent, as it says up here. So I know that 68 is the full length. from A to C. I know that from B to C is 43. So if I subtract those two, I should get how much is left over for this little guy right here, right? If I take the full 68 and I cut off this 43, that means I'm going to be left with however much is left for the AB part, which in this case, 68 minus 43 would give me a nice crisp 25. And that'd be that. So once again, this problem is a little bit of a doozy because there's a bunch of steps you have to go through and a bunch of procedures you have to go through in terms of plugging stuff in and figuring stuff out and whatnot. But it is using all the stuff we've kind of learned about segments. This is like a comprehensive review of all the segment properties that we talked about. There's midpoints, there's doubling a number to set up an equation, right? We have to double a side length to write it down twice in order to get the total side length because it's involved in the midpoint. There's plugging the stuff back in. There's taking the big piece and subtracting the small piece to get the other little piece. So again, there's everything that we did with segments is kind of tied up in this little problem right here. So if you have trouble with it still, let me know. Once again, if you think I made a mistake in my math, let me know. I'll be glad to correct it in the description. Otherwise, hopefully you enjoyed this video. Have a good day.